my beautiful students, so welcome back to KCET Masterstroke target 1000 rank. So here in this chemistry session we are going to discuss about the alcohol, phenols and ether. So yes, without further delay, let's get started. So yes, if you are preparing for KCET, then please enroll yourself in ABHYAS KCET test series, because this will give you the clarity about your preparation, and the complete examination hall like simulation will make you prepare for the final KCET examination. So yes, without further delay, let's get started. So here in this lecture, what you are going to learn: first, classification and nomenclature, structure, preparation of alcohol, preparation of phenols, physical properties, next chemical reaction of alcohols, chemical reaction of phenols, commercial alcohols and ether. Okay, so yes, let's first start with the classification of alcohols and phenols. So classification can be done with respect to the number of OH group, sp3 carbon and OH bond, and sp2 carbon and OH bond. Okay, so now in case of sp3 carbon and OH bond, you can split it further. You can proceed with alkyl alcohol, allylic alcohol and benzylic alcohol, and whenever it's the matter of sp2 carbon and OH bond, it can be vinylic alcohol and phenols. That's it. So let's proceed with the example. This is with respect to the number of OH group. It can be, if one OH is present, monohydric, 2 OH is present, dihydric, 3 OH is present, trihydric. Next, this is sp3 carbon and OH bond. The way I told you, alkyl alcohol. Alkyl alcohol can be further classified into 3 parts. One is primary, secondary and tertiary. If the carbon containing OH is attached with 1 carbon, that is primary. If the carbon containing OH is attached with 2 more carbon, it is secondary. If the carbon containing OH is attached with 3 more carbon, it is tertiary. Next, we will proceed with the allylic. Allylic means C double bond C, single bond C, OH. Okay, one double bond, one single bond, that carbon is containing the OH. So what I said, carbon, double bond carbon, single bond carbon, OH, that is the allylic unit. Okay, so in that particular case also, the allylic carbon can be primary, secondary and tertiary. Okay, you can see the examples are given here. Next is benzylic. Benzylic means the carbon that is holding the OH, that same carbon is holding the benzene ring as well. That also can be classified as primary, secondary and tertiary as well, the way it's given here. I guess it's clear. Let's proceed further. This is sp2 containing carbon plus OH. Here comes vinylic and phenolic. Okay, so vinylic means directly that carbon is holding the double bond as well as the OH. So C double bond C, OH, that's it. So similarly, vinylic carbon is also present in the benzene as well. Benzene is directly holding the OH, that is basically the phenols. Okay, we can have monohydric, dihydric. Okay, this type of example we can have. Okay, let's proceed. So here comes the examples of ether. We can get symmetrical ethers as well as asymmetrical ethers. Symmetrical ether means if you just cut that ether with respect to the oxygen, both the side you will be having same moiety. Asymmetrical means both the side you will be having different moiety attached to it. Next, this is the nomenclature. Don't go to that much depth while discussing the nomenclature. Basic you remember, that's it. That will be okay. Let's proceed further. Here you can see it's for the phenols nomenclature. This is orthocresol, metacresol, paracresol, that you remember. If toluene is containing OH, then you can call it cresol. And with respect to the position of the OH group, if they are ortho with respect to each other, then it is ortho, meta, then metacresol. Like that you can name it. And here if you are having 2 OH group with the benzene ring, we can name it as catechol. Catechol is when the OH groups are attached in the consecutive carbon. They are ortho with respect to each other. If they are meta, this is called resorcinol. If they are para, they are called hydroquinone. Like that. I guess it's clear to you. Let's proceed further. This is the common names of some ethers. You can just simply have a vision on it, that will be more than enough. Okay, let's proceed further. Okay, just let me tell you a very important thing. If you want to get a free mock test to realize where you are actually standing in preparing your KCET examination, just below your video, maybe you are watching my video or physics or chemistry in the Masterstroke series, just below the video you will see a free mock test link over here, the way it's observed here, you can see. Okay, so once you will just click in this particular link, this particular site will be opened. Just put your mobile number here, you will get the OTP and you will get this entire test series free of cost. So yes, my student, make sure that you are testing yourself before you are going for the final examination. So don't miss out this chance of a free mock test. Please try yourself. Thank you. Next, we will proceed with the structure. So structure, definitely when it comes to this carbon OH bond, this carbon is definitely sp3. Okay, methanol if you are discussing about, then this bond you can see carbon oxygen hydrogen, this bond angle is 108.9 degree. Why? Because the lone pair bond pair repulsion make the bond a little bit shorter, right? So now here you can see whenever it comes to the matter of alcohol, I mean phenol, so this is the 136 picometer, this is the bond length. Why? The bond length is shorter than that of the expected carbon oxygen bond length, single bond length. Why it is so? It is because of the phenol oxygen lone pair takes part in the resonance. As a result of this, these particular bond gets some partial double bond like character. As a result of this, double bond comes here, partial double bond character comes here, so bond length decreases a little. Okay, next this is the ether, the bond angle you can see 1.7 degree. Just a little bit reminder, you can just remember about it. Okay, let's proceed further. Okay, so here alcohol, phenols and ether, we will proceed with the preparation of alcohols, preparation of phenols and physical properties. Okay, one by one we will study. So first we will go through preparation of alcohols. You can see from alkenes we can prepare, from carbonyl carbon we can, I mean carbonyl compounds we can prepare, from Grignard reagent also we can prepare. So now here whenever it's the matter of alkenes, it can be acid catalyzed hydration, it can be hydroboration oxidation. Next, whenever it comes to the matter of carbonyl compound, reduction of aldehyde and ketone and reduction of carboxylic acid and ester. Okay, so yes, let's start with these preparation. Okay, don't get confused that so many things are accumulated together. No, we are trying to make represent a brain map form so that you remember how we are going. Okay, then also whenever we will write down the reaction in the same page, all the reaction will be covered. You will understand that if you remember that brain map, it will be more than enough for you. Okay, so yeah, let's proceed. So here comes the preparation of alcohol. Okay, so here you can see I have to prepare alcohol. Let's write it in the middle. Okay, so I can start from the alkenes. That was the first one, right? Okay, so from alkenes I can proceed with two different ways. What are the two ways? First, we can proceed with the acid catalyzed hydration, right? So I can give simple H plus and H2O. Okay, another thing what I can do is I can do hydroboration oxidation. So let's give the reagent BH3 whole twice in H2O2 in presence of OH minus. Okay, this is from the alkene. These are the two options that we had been through. Okay, so now let's proceed with the next option. Let's start from the aldehydes and ketones. Okay, so if you start from the aldehydes and ketones, so from aldehyde ketones also you can proceed with two different ways, right? First one, first one, what you can do is you can give H2 in palladium, right, normal hydrogenation, or you can give NaBH4. Okay, this is another way. Another way where what I can do from the ester or acid, right? So we can start from acids or esters. Okay, so from here how can I go? How can I go back to alcohols? I can simply give some lithium aluminium hydride. I can simply give some lithium aluminium hydride. Okay, one more thing, that I can start from the Grignard reagent, right, RMGX. Okay, so if you are starting from RMGX, okay, so here you can just simply give some aldehyde. Okay, you can simply put some aldehyde over here and you will come back to alcohol. That's it. So these are the general methods to prepare the alcohol that in a single page you can see. Further, if you proceed, this is the preparation of phenols. So here from the haloarenes we can prepare, from benzene sulfonic acid we can prepare, from diazonium salt, from cumin. Okay, so yes, let's do it one by one. So here all the conversions are very important, specifically the last one, cumin to phenol synthesis, very important. Let's proceed. Okay, so here just let me draw. I have to come up with phenol, right? I have to come up with this. Okay, so from where I should start? First I can start from haloarenes. Okay, let's begin with haloarenes. So let's say if I am having Cl, okay, chlorobenzene. So from here, if I give some NaOH in presence of heat, let's say 623 Kelvin to 300 and 300 atmosphere and 300 atmosphere. Okay, so you can end up with the formation of ONA. Okay, so now from here you can just simply give HCl, okay, to come up with the phenol. This is from the haloarenes. Okay, next you can see from sulfonic acid. Okay, so how you can prepare sulfonic acid? Let's say you are having simple benzene. Okay, in simple benzene give some oleum. Okay, then it will be benzene sulfonic acid, that is SO3H, right? In benzene sulfonic acid simply give NaOH in H+. It will give you the phenol. Okay, next what you can do, let's say from amine, let's say I'm having NH2 with benzene ring. From here I can prepare the diazonium chloride. Okay, what is the condition of diazonium chloride? NaNO2 in presence of HCl. Temperature I must keep 0 to 5 degrees Celsius. Okay, you will end up with benzene diazonium chloride, N2 plus Cl minus. So over here just a little bit heat and give some water, you will end up with phenol. Okay, last most importantly, that is cumin to phenol synthesis, right? So what is your cumin? This one, benzene with one isopropyl group, CH3, here also CH3. Okay, so if you give oleum, sorry, if you give O2, you will end up with some peroxide compound. OH. Okay, now from here to phenol, you can just simply give some acid in presence of water. Aqueous workup you can do. So this is your cumin to phenol synthesis. So this is all about the preparation of phenol. I guess it's clear to you. Yeah, let's proceed further. Here you can see the physical properties, boiling point and solubility. Boiling point, it definitely increases as the number of carbon atom increases because the van der Waals force increases, right? And decreases with the increase in the branching, right? Because with the branching, surface area decreases, right? That's the result. You can say the boiling point decreases. Okay, solubility, due to their ability to form hydrogen bond, it is very soluble. It is very much soluble in water molecules. But as the size of the alkyl group increases, the hydrophobicity increases, hence water solubility decreases. Next, okay, one problem is there, compound P and R. Okay, we have to find out what type of isomers or they are similar. Okay, let's see. So we are having CH3CHO, right? CH3COH. Here I am giving CH3MgBr, right? CH3MgBr. So this CH2 group will attack over here, this bond will open up, and here if you give H3O plus at the end, then you will end up with something like CH3C, here OH, here H, here CH3, right? So that is your P. Okay, now from here I am giving concentrated H2SO4. I am giving concentrated H2SO4. Okay, and heat. So definitely it will undergo dehydration. So I will get something like CH2 double bond CH3. Okay, further if you do B2H6, hydroboration oxidation. If you give B2H6 and you give H2O2 in OH minus media, this is hydroboration oxidation, hence you will get the OH at the terminal carbon, right? CH2, CH3. Okay, now what is the thing? This is my Q, this is my R. They are asking what is the relation between P and R, right? So P and R, you can see both of them are having OH group, okay, but the position is different, so they are basically position isomers. Okay, I guess it's clear to you. Let's proceed further. One more problem, okay. So let's do it. So I'm having the compound something like this. Okay, now here I have to add CH3MgBr. So CH3MgBr. So this will attack here, this will open up as a result of this in presence of ether, right? In presence of ether, you will get something like this. Here you will get one OH. Okay, now you have to name this. So 1, 2, 3, 4. So what is the name of this? 3-methyl. In the 3 position I am having one methyl group. Butane to all. What is the option? This option A, 3-methyl butane to all. I guess it's clear. Let's proceed further. Okay, so one more thing about the KCET, that Deeksha Karnataka channel has brought up with a new series, that is KC30 batch. So these are the offerings. You can see 30 days live online crash course this is, and previous year question with solution you will get. Complete syllabus of PU1 and PU2 will be covered here, and chapter wise previous year question in the test format you will get out of it. Okay, and 10 full length KCET mock test you will get out of it. The live batch you will get from 8 AM to 7 PM on a regular basis. It's going to be started on 21st March, and you are getting this thing only at 2499. So yes, without further delay, please enroll yourself in this KC30 batch. So basically, what's the difference between KC30 and ABHYAS KCET test series? In KC30 batch, you will get your live session from the expert teachers, and you will get these batches as you can see, live online crash courses, and along with that, any doubts that you will get, it will be solved by the expert teacher who are actually teaching you in the online session. So yes, without further delay, enroll yourself, take this test series, and any doubt, if you're studying today, so yes, this is the best option for you. Go ahead with it. You are definitely going to get top 1000 rank in KCET. Yes, let's further proceed. One more problem. Okay, so I'm having ethanol giving PCl5. So okay, let's start. We are having C2H5OH. Here I am giving PCl5. Okay, so it will give you C2H5Cl. Right, now what I am going to do? Alcoholic KOH. Okay, once I am giving alcoholic KOH, let me just write down this structure properly. Once you are doing the alcoholic KOH, okay, so this is the thing, right? So basically, once you are giving alcoholic KOH, it will perform dehydrohalogenation, or you can say beta elimination. Okay, so this hydrogen will jump here, this chlorine will leave the system, and hence CH2 double bond CH2. Okay, this is your Y. Now what you are going to do? Here you are going to give H2SO4. So once you are giving H2SO4, definitely one alcohol group will come. So CH3 CH2OH. This is the thing. Okay, so yeah, this is the hydration reaction, acid catalyzed hydration reaction from alkene to alcohol. Okay, so the product Z is definitely going to be option D. Okay, I guess this is clear to you. Yes, let's proceed further. Okay, so this is a part 3. First, here we will study the chemical reaction and of alcohols and phenols. Okay, so first you can see alcohols can behave both as electrophile and nucleophile. Okay, so first here you can see alcohols as a nucleophile. How it behaves, let me show you at first. See here, let's say I am having ROH. Okay, let's say I am having one carbocation. Maybe it is coming out of SN1 reaction. Okay, so this OH can attack over here as a nucleophile. Okay, as a result of this, the system that you will end up with, that is ROH, here one plus sign, here C, this. Okay, further it will release this H plus, okay, and this bond will jump on oxygen and you will end up with ROC, this. Okay, so this is how it can react as a nucleophile. Okay, I guess it's clear to you. Let's proceed. So here we will proceed with alcohols as an electrophile. So let me show you. So alcohol, to perform as an electrophile, we have to make OH, precisely oxygen, as positive. Okay, so let's make it. What we will do? We will do protonation. So RCH2OH. Okay, so do protonation, treat it with acid, it will be RCH2OH2 plus, right? So now what will happen? So now here you can see, let's treat it with Br minus. So what will happen basically? Br minus will attack on this carbon and this will leave the system. As a result of this, you will get RCH2 Br plus H2. Okay, so here in this particular step, OH2 plus is working as an electrophile. Okay, I guess this is clear to you. Let's proceed. So protonated alcohol is the electrophilic version of it. Let's proceed. Here we will proceed with the reaction of alcohol. So reaction of alcohols we will go through in two different way. First, cleavage of OH bond and cleavage of CO bond. So here you can see whenever cleavage of OH bond, we will study reaction with metals, acidity of alcohols and esterification. Cleavage of CO bond, we will proceed with reaction with HX, reaction with PX3, dehydration and oxidation. This much. Okay. So first we will study cleavage of OH bond. Okay. So we have to come up with, sorry. Okay. So we have to start from ROH. Right, remember this OH bond, this bond needs to be cleaved, this bond needs to be cleaved. Okay, so what are the options? You can see first we can proceed with the reaction with metals. Okay, so first let me just treat this thing with sodium metal. Okay, you will end up with RONA plus H2. Fine. Next we can proceed with acidity of alcohols. Okay, so acidic nature we will proceed with. So let's treat this thing with RCOCl. Let's treat this thing with another R prime OCl. Okay, so here we will end up with R O C double bond O R prime plus HCl. Okay, so basically what is happening here, if you just keep this ROH along with that this thing ClO R prime, right? So here H and Cl will be released, okay, and this will make the bond. Okay, this is COCl and this thing will be bonded like that. You can see ROCO R prime like that. Okay, so now next what you can give, here you can give R prime COOH. Here you will end up with some ester group, that is ROCO R prime plus H2O. Okay, so these are the all possible options that you can end up with. Okay, I guess this is clear to you. Okay, let's proceed further. Here we will proceed with the cleavage of CO bond. Okay, so definitely we have to start with ROH. Here this bond needs to be cleaved. Okay, so now yes, let's proceed. So first what we will do here, we will do let's say dehydration. Let's do first we will do dehydration. So what is the reagent that we have to give? H2SO4. Okay, H2SO4 in 443 Kelvin, or I can give H3PO4. It will work similarly. I will end up with alkene unit. Okay, so for the dehydration, carbocation will be generated, right? So if this alcohol, if this R group is 1 degree, 2 degree or 3 degree, this will matter. Okay, the reaction rate will be matter. So definitely for 3 degree, it will be greater 2 degree than 1 degree. This is the rate of dehydration. Okay, rate of dehydration. Okay, next one more. Let's say I am giving here HX. Okay, so I will get RX here, okay, and H2O. Okay, next let's say here I am giving PX3. Okay, this X can be Cl or Br. Cl or Br. I can get RX out of it. Okay, so these are the all probable reaction where the involvement of carbon oxygen bond occurs. Okay, next oxidation. Let's proceed with some oxidation reaction. So first we will study with CrO3. Okay, so under CrO3 what we can proceed with? We can give, let's say, RCH2OH. Okay, one thing before proceeding with the oxidation, one more thing, the general trend of oxidation. Let me just show you. If you are having, let's say, RCH2OH, if you do one step oxidation, okay, it will end up, you will end up with aldehyde. Okay, again one step oxidation, okay, you will end up with carboxylic acid. Okay, like that actually this process takes place. Okay, so aldehyde on being processed with CrO3, you will end up with aldehyde, single step oxidation. Okay, let's say you are having 2 degree. You are having 2 degree alcohol. You are giving CrO3, you will end up with some ketone. Okay, next we will proceed with, let's say I am having the reagent PCC, pyridinium chlorochromate. I am having PCC. So here also, if you start with 1 degree alcohol, RCH2OH, you will end up with, on being treated with PCC, it will be RCHO. Okay, next we will proceed with another reagent, that is copper. Okay, we will give copper at 573 Kelvin. Okay, temperature you have to remember. So here in this case, if I, let's say, start with RCH2OH, that is 1 degree, you will end up with aldehyde RCOH. Okay, Cu 573 Kelvin. I am not writing the reagent again and again, the same reagent you have to give. Let's say you are having this thing, means 2 degree. Okay, here one H. I know you people will comment otherwise, ma'am, the carbon valence is not met up. Anyway, so R prime, here also in presence of copper, you will end up with ketone. Okay, now let's say I'm having 3 degree. Let's say 1 methyl OH, here methyl, here methyl. Here comes the magic. Here comes the magic. Okay, let me write the CH3 group, it will be better. So here, if you are having 3 degree, on being treated with copper 573 Kelvin, you will end up with dehydration. So CH3, single bond C, CH3, here double bond CH2. That's it. Okay, so these are the sets of reaction that is involving the oxidation. Okay, here also the involvement of CO bond cleavage takes place. Okay, I guess it is clear to you. Let's proceed. Okay, reaction of phenol. So you can see first acidic nature we will study, then esterification, electrophilic substitution, Coles reaction, Remet-Timan, reaction with zinc dust, and oxidation. So these are the things we will study. Okay, electrophilic substitution we will study, nitration, halogenation. Okay, so all this reaction we will study definitely in a single page. Okay, so let's proceed. So we have to start from phenol, right? Okay, starting from phenol, how you should proceed. First reaction is something, okay, let me check. First is acidic nature, right? So yes. Okay, so here let me just treat this thing with sodium metal, Na. Okay, so you will end up with phenoxide. This is ONA plus H2, hydrogen gas. Let's say if it is acidic, if phenol is acidic, it should react with some base. I am giving here NaOH. So here also you will get sodium phenoxide, that is ONA plus H2O, salt plus water. Okay, now I am treating this with HNO3, diluted HNO3. Okay, so dilute HNO3, it will be substituted with the nitro group. Okay, so nitration. See, the nitro group can come in the ortho position and in the para position as well. Okay, next if I treat this with, let's say, concentrated H2SO4, sorry, concentrated HNO3, then all the ortho and para position will be substituted with the nitro group. So NO2 here, NO2 here, and NO2 here. Here I am having OH. Okay, next halogenation, let's do. I'm adding, let's say, Br2 in presence of carbon disulfide. Okay, so definitely Br will be added. So Br will be added in the ortho position and in the para position. So here in the para plus here in the ortho position. Okay, now I am adding, let's say, Br2. Okay, so now ortho and para, all of them will be substituted with Br and Br. Okay, so now what we are going to do, okay, these things are done. Next we will proceed with halogenation, nitration is done, Coles reaction, Rimartiman. Okay, let's proceed. Coles reaction. Okay, so in Coles reaction what we do, first we will treat this with NaOH. So once I will treat this with NaOH, I will get ONA. Okay, now in ONA what I will give? I will give some CO2. Okay, I will give carbon dioxide in H plus. Okay, so once I will give it, I will end up with salicylic acid. This is COOH. So what is this reaction? This is your Coles reaction, right? So this is your Coles reaction. Okay, so now what I can do is further I can just show you one thing. Okay, let me just proceed a little bit. One more synthesis, one more important synthesis I can show you. From here, from salicylic acid itself, if you do acetylation, let's say as H plus and CH3CO whole twice O. Okay, so if you do acetylation reaction, you will end up with aspirin. Okay, this is one of the analgesic, first ever discovered analgesic medicine. Okay, OCOCH3. This is your aspirin. Along with that, you will end up with CH3COOH. Okay, so no more place. We still have a few more reactions. So Coles reaction, then RT reaction, reaction with zinc dust, and oxidation. Let's proceed. I guess you understood up to Coles reaction. Okay, so let's proceed further. So from phenol I have to start. Okay, let me start from here. Okay, so first we will proceed with the Rimartiman here. Okay, so what I have to give? I have to give chloroform, right? That is CHCl3 in presence of aqueous NaOH. Okay, I will end up with this. Here I will get ONA and here I will get CHCl2. Fine, now you give further NaOH here. Okay, so you will get here ONA and here CHCl2. Sorry, here you will get CHO. So further just simply water if you give, this ONA will be converted to OH and here you will get, sorry, here you will end up with CHO. This is salicylaldehyde. So what is this reaction? This is basically your Raymat-Tiemann reaction. So yes, just let me just name it as RT reaction. I guess it is clear to you. Yeah, let's proceed further. One more reaction. One oxidation we will do in presence of Na2Cr2O7. It's a very important thing. Question comes out of it. H2SO4. Okay, you will end up with benzoquinone formation. Okay, this double bond, wait. Double bond O here, double bond O here. Fine. Now reaction with zinc dust. If you give zinc dust, it will be simply going back to benzene. Okay, it will go back to benzene. Along with that, you will get ZNO. That's the thing. Okay, I guess it is clear. This is the all reaction. This thing and this thing, all reaction of phenols. Okay, let's proceed. Okay, so here we will study. Okay, one more thing I guess I missed here. Zinc dust, oxidation. Okay, one more thing, esterification reaction we have to proceed. Okay, so yes, the last one, sorry. We will do esterification. Okay, in esterification, what we will do? Here definitely we will start from phenol. And let's take one carboxylic acid. Let's say R prime COOH. So you will end up with this thing. OCO R prime. So we will end up with some A star group. Let's say I am giving some anhydride type of thing, R prime CO whole twice O. Okay, here also you will end up with the A star, sorry, OCO R prime. Along with that you will end up with R prime COOH. Okay, now if you give acyl chloride, let's say R prime COCl, then also you will end up with the A star. R prime plus HCl. That's it. Okay, this is all about the esterification reaction. I guess it's clear to you. Yeah, let's proceed. Commercial alcohols and ethers we will proceed. So commercial alcohols are methanols and ethanols. Okay, and ethers we will proceed with methods of preparation, physical properties and chemical properties. Okay, so here you can see methanol preparation. So first is wood spirit. Okay, so we can get it out of destructive distillation, okay, of wood. Okay, so what you will get? Carbon monoxide plus water. In this case you need some zinc oxide and Cr2O3, this type of catalyst. You will end up with the methanol CH3OH. This is a colorless liquid, poisonous in nature, and you can use it as a solvent in different type of varnishes, paints. Okay, like that. Let's proceed. Ethanol. So ethanol, let's say you are having fructose type of thing. Okay, sorry, not fructose, sucrose. Okay, so in case you are having sucrose, first in presence of invertase, you can just break it down in the form of glucose plus fructose. Okay, now that particular glucose or fructose further can be treated with zymase enzyme that can give you the ethanol molecule. It's also colorless, it's also poisonous. You can use it as a solvent, okay, in varnishes, paints, etc. Let's proceed. Here we will proceed with the preparation of ethers. So first is dehydration of alcohols. Next is Williamson ether synthesis. Okay, so one by one let's see. First we will study dehydration of alcohols. So let's say I am having let's take one alcohol. 3 steps takes place. Okay, one by one all the steps we will I will show you. First is protonation of OH, that takes place. Okay, so here what happens basically, let's say I am having this type of alcohol. wait. This type of alcohol you are having, let's say I am giving H2SO4 to it. Okay, this particular alcohol will be protonated. That is OH2 plus. Your next step is the formation of carbocation. Your next step is to formation of carbocation. Okay, so what happens in this step? In this step you can see this particular OH2 plus, it leaves this OH2 plus, this leaves as a leaving group and you will end up with a carbocation. Okay, so here you can see here you will get the carbocation in this carbon, right? Here you will end up with the carbocation, right? But now if this carbocation comes here, it will be more stable. So here I am having one hydrogen, so this hydrogen will jump here and this carbocation will be shifted. Okay, so here I am taking what is going on, hydride shift. One hydride shift will give the carbocation some more stability, hence you will end up with this type of system. Sorry, this carbocation is comparatively more stable because it is of 3 degree, right? So now let's proceed with the last step, that is the deprotonation. So last step is deprotonation. Okay, so deprotonation, so from there we will start. I am having this carbocation, this thing, here I am having one hydrogen, right? So now I am having water in my medium, this water will takes up this hydrogen, this bond will jump here. As a result of this, see what you are getting? You are getting one alkene. Okay, I guess this thing is clear. So first is protonation, then formation of carbocation. If possible, give the carbocation some extra stability by hydride shift or methyl shift. Then deprotonation will give you back the alkene. This is dehydration of alcohols. Next, proceed with Williamson ether synthesis. Very important thing, SN2 type of reaction. It is an SN2 type of reaction. Okay. So yeah, let's proceed. Let's say I am having ROH. If you treat it with sodium, it will give you RONA. This RO minus Na plus, right? This RO minus, it will react on any kind of alkyl halide. This O minus will attack over here, the Cl will leave the system. As a result of this, you will get something like this. Okay, let me just let it be R prime. So RO R prime, okay, plus NaCl. This is your Williamson ether synthesis. I guess it's clear to you. This is how you can just proceed with the preparation of ethers. Okay, so yeah, let's proceed. Physical properties, you can see the carbon oxygen bond in ether, this is polar in nature, thus it is having some sort of dipole moment. Next, it is soluble in water because it can form hydrogen bond, right? Next, here you can see chemical properties we will study. Reaction that is involving CO bond cleavage, electrophilic substitution. In electrophilic substitution, we will study halogenation, nitration and Friedel-Crafts reaction. Okay, so CO bond cleavage at first, let's proceed with. First, let's say I'm having R1O R2. Okay, let's say I'm giving here some HX. Okay, so this oxygen will be protonated at first. Okay, so I will get R1O plus, here H, here R2, right? So now let's give X minus. Okay, let's give X minus. I will get R1 here OH plus R2 X. Okay, so this is the thing. So here few things that you have to remember. Let's say if R1 and R2. Okay, both are 1 degree and 2 degree or 2 degree, both 1 degree, 2 degree, then this reaction will take place in SN2 way. Okay, but if any one of them, if any one of R1 and R2, it is 3 degree or resonance stabilized, then SN1 will take place. Remember this thing. Okay, so this is all about the cleavage of CO bond. Now we will proceed with the electrophilic substitution. Okay, so in electrophilic substitution, let's say I am having some this type of thing, one ether, OCH3 group attached with benzene. This is an ether group. Okay, so here we will do some electrophilic substitution. So first let me do, let's do halogenation, Br2 in presence of, let's say, acetic acid, CH3 COOH. Now in the ortho and in the para position I will get bromine substitution. Here also bromine, and here also I will get in the para position bromine. Okay, next let's do Friedel-Crafts. Let's say RCl AlCl3. So here also the alkyl group will be substituted. So the R group will be substituted here. So in the ortho position I will get here R OCH3 plus in the para position also I will get R. Okay, so what is this reaction? This is Friedel-Crafts alkylation, right? Okay, so now we can proceed with the acylation, Friedel-Crafts acylation. Here we will treat this thing with RCOCl, means one acyl chloride group in presence of aluminium chloride. Fine, here acyl group will be substituted in the ortho and in the para position. OCH3, here I will get CO R plus one more in the para substitution, OCH3, here I will also get COR. Okay, what is this reaction? This is also Friedel-Crafts acylation. Okay, next what I can do? I can do nitration. I can give concentrated HNO3 plus concentrated H2SO4. Okay, so nitro group will come definitely in the ortho and in the para position, because OCH3 group is ortho para didactic. Here OCH3 plus here also OCH3 I am getting in the para ortho position. Okay, so this is all about the electrophilic substitution reaction. So that's all. So yes, here we are ending up with the chapter. So I guess you understood alcohol preparation, chemical reaction, physical properties, then phenol, the chemical reactions, preparation of phenols, and then after proceeding ethers, right? Preparation of ethers, chemical reaction, properties, okay? And this is electrophilic substitution. You are ending up. So soon we will come up with the previous year questions of this particular chapter. So yes, so to get more such video, don't forget to like, share and subscribe our channel. Thank you so much.